All right, a little bit more difficult ones here. Addition of opposite directions. I'm sorry, another example of the same one. The reason I want to show you this one is up and down. We could turn our ruler vertical if we wanted and go up and down, but we don't need to. As long as you define your directions, I can go, oops, I need my pen tool. Sorry about that, I bumped the button. As long as I go here and I mark my directions as up and down. As long as I do that, then I don't actually need to go up and down. So pull my ruler up, and I'm going to grab my line tool. I'm going to draw now. Oh, I also need a scale in here, that too. My scale, 12 and 3. I should be able to go just one scale. 1 centimeter equates to 1 meter. So 12 meters up direction, which I've defined as to the right. 12 meters is 12 centimeters. There you go. Plus 3 meters in the down direction. Turn my ruler around here. And I draw a line 3 meters or 3 centimeters in the down direction. And I go from the beginning of the first one, which would be, spin this around, beginning of the first one to the end of the second one, and I get 9 centimeters or 9 meters in the up direction. So my answer, 9 meters up. I got 2 more examples for you here. One is a simple subtraction. So 3 centimeters right minus 4 centimeters right. Anytime that you are subtracting graphically, it's the same thing as adding the negative. So in other words, 3 centimeters right minus 4 centimeters right is the same thing as 3 centimeters right plus negative 4 centimeters right, and negative 4 centimeters right is the same thing as 4 centimeters in the opposite direction or left. Hopefully you follow that. So I'm going to Just pull up my ruler. And now it's no different than this example, adding in opposite directions, right? We're adding in opposite directions. So, oops, back to this one. So we just need to draw in, and again, we don't need a scale because we're working in centimeters and small numbers of centimeters. So we need 3 centimeters to the right, plus 4 centimeters to the left, now I should have done this with more room, and if this happens to you, you'll have to use an eraser and start again. Luckily, I can just grab this, pull it over. Otherwise, I'm not going to be able to draw 4 centimeters to the left. 4 centimeters to the left. And again, we measure from the beginning of the first one to the end of the second one is 1 centimeter, and it is to the left. So our answer, 1 centimeter left. One final example, subtraction of opposite directions. So we just need to work this out now. 12 meters east minus 2 meters west. So that's the same as 12 meters east plus a negative 2 meters west. Sorry. And negative 2 meters west is the same thing as positive 2 meters east. So 12 meters east plus 2 meters east. And now it becomes a very simple one, just like our first example. Here, adding 2 in the same direction, 2 positive numbers in the same direction. So we grab our ruler, pull it up. We need to define our directions. As west and east. We also need to define a scale for this one. We should be able to 12 and 2, we should be able to go 1 meter equals 1 centimeter, or rather 1 scale, 1 centimeter is 1 meter. And then we can draw our lines in. 12 meters east plus 2 meters east. Oops. and then use a ruler to measure from the beginning of the first one to the end of the last one. 14, I wasn't very careful with this one, so you can tell I'm a little bit off, but 14 centimeters or 14 meters to the east is our final answer. All right, that's how you measure, how you calculate the addition and subtraction of vectors graphically in one dimension. We'll do some more videos when we get into two-dimensional adding and subtracting of vectors.